Antimatter. Yeah, so I got you started there. This is a question from OpenStack's College Physics, Chapter 22, number 14. So it says, imagine that you have an antimatter storage system like in Star Trek. You really don't even have to say Star Trek because there's other things that use antimatter too. And so the idea of antimatter is if you have an antimatter proton, it would be almost the same as a proton, same mass, but it have a negative charge. And so now if I have a positive proton and a negative proton, an antimatter proton, they'll attract, and there's nothing to prevent them from coming onto each other and they annihilate. And when that happens, they turn into energy, a lot of energy. So you can get a lot of energy from an antimatter storage system, but you got to make the antimatter, which we can do. You got to store the antimatter, which we can do. But overall, it's still a very difficult process to do. So in the problem, it says one way to store antimatter is with a magnetic field. So if you get an antimatter proton moving in a circle in a magnetic field, it doesn't have to touch the containers of the wall, which are made of normal matter. And so it wouldn't annihilate with the normal matter. And that's what you want. So a vacuum, no air, proton, antiproton moving around. So here we have a magnetic field. And remember the convention for three-dimensional vectors. If it's going into the board, it looks like a cross because you're looking at the back of the arrow. So these are vectors going into the board. Here's my negative charge going this way, moving in a circle. Okay, so let's just review a couple of things. Number one, if I have a moving charge in a magnetic field, I can calculate the magnitude of that force as QVB sine theta. So that's the value of the charge. It's a proton, it's antiproton, so it has a charge of negative 1.6 times, I didn't put a negative sign there, negative 1.6 times 10 to the negative 19th coulombs, same as an electron. The velocity they give us is 5 times 10 to the 7th meters per second. We're trying to calculate the magnetic field, but what about this theta, sine of theta? Well, in this case, if the charge is moving in this plane and the magnetic field is into the board, then those two would have a 90-degree angle. So the sine of 90 is 1, so that term just goes away. That's good. What about the direction of that force? We should talk about the direction. So here we have to use the right-hand rule. Remember that if I have my charge is moving this way, then I want to think about what's the direction of QV. So since it's a negative charge, QV is actually this way because it's negative charge. Okay. So now I want to say what vectors are perpendicular to both QV and B. So there's only two, right? Since B is into the board, B is this way, I could either have it this way or this way. Those are the only two that are perpendicular to both of them. Now I can use my right-hand rule. So I'll use my right-hand rule. I want to let my fingers curl through QV and then B, and then it would be this way. So I made my little tool here. Okay. So here I have the three arrows that you can use. You can use your fingers too, like this. But if I put QV in the direction of QV, I put B in the direction of B into the board, right? Then I get the force this way. And so the nice thing is that force, that sideways force, is going to make it turn direction. So now QV is like that, but still the force is going to be always pointing towards the center of a circle. And so that's how we get circular motion. So this is, we don't need to derive this, but I'm going to. So here's QV, there's F, and so I can use my ideas of circular acceleration from my last semester of physics. F net in the R direction is going to be equal to QVB sine of 90, and that's going to be equal to the mass times V squared over R. This is mass times acceleration. Circular acceleration is V squared over R. Okay, so that's good. Now what we want to do is to solve for B. That was the question, right? So I can just solve this equation for B first. That cancels. So I get B equals not V squared, V over QR. That's it. Now I know the mass, I know the velocity, I know Q, I know R. They gave it all to us. So we're just going to plug in. So it's not a super complicated equation, but you have to be careful about putting this into your calculator. So what it was, mv over qr. So let's put the numbers out here. The mass of an antiproton is the same as the mass of a proton, 1.6 times 10 to the negative 27 kilograms, 1.67 times 10 to the negative 27. The velocity was given, 5 times 10 to the 7th. The charge is 1.6. I'm not going to put in negative. I've already taken into account the negative QV for my direction up there. So I'm just going to put 1.6 times 10 to the negative 19. And then I have R is 2. Now, I think it's kind of fun here just to play a little game. Let's just see how far we can get without using a calculator just for fun. Okay, so the first thing I'm going to do is I have 10 to the negative 27th and 10 to the 7th. I can change those order of operations around. Multiply, 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 multiply. I can change the order. So here I have 10 to the negative 27th times 10 to the 7th is 10 to the negative 20th. So let's just change that. I'm going to get rid of that, and I'm going to make this 20. I can do that. If I want, I can actually multiply these two numbers together too. That's not too bad, but let's just not do that right now. Now I'm going to divide 10 to the negative 20th by 10 to the negative 19th. I can do that too. So if I do that, I'm going to say this is like 10 to the 19th, right? If I pull it to the other side of the fraction, it's like 10 to the 19th. Now I have 10 to the negative 20th times 10 to the negative 10 to the 19th is what? It's 10. You see how fun this is? Now I have 1.67 times 10. I can just move this decimal over, and I get 16.7. So now you see we're making some progress here. I'm going to estimate the value here, and then I'm going to put it in my calculator. Okay. So I have 16.7 divided by 2. I can do that. That's 8, and then I have 8.35. So this is 8.35. Actually, no, wait. I'm going to take this and divide by that, and I'm going to get 10, right? It's about 10, right? Because 16.7 is very close to 1.6. So when I divide those, I just get 10. So that's 10 times 5 is 50, divided by 2 is going to be approximately 25 Tesla. Let's see how close I got. I got pretty close, I'm pretty sure. Okay, so the scientific notation stuff I'm fine with. 16.7, enter, 5 times. 1.6 divided by 2 divided by 26. Okay, I said approximately. And that's a win for me. And you, for watching me win. Okay, so it wasn't too difficult of a problem. We need to practice using our right-hand rules and visualizing this force due to a charge moving in a magnetic field. It takes some practice.